we will take a look at two questions that were asked by Pankaj. The first question that he asked was, the most stable enolic form of 2,4-pentane dione is, and these are the four options. Okay, so before I solve this question, let us see what an enol is. So enol is made up of two parts, en and ol. Ol means an OH group and En means C double bond C. So whenever in any compound you have a C double bond C next to an OH group, it is called an enol. Right? It is the tautomer of ketone. Okay, so let's look at this question now and see what is the correct answer. The first option that we can easily eliminate is option number C. Why? Because there are only 4 carbon atoms here. You can count them 1, 2, 3 and 4. But in pentane we should have 5 carbon atoms. So C is wrong. Now we are left with A, B and D. Now let's take a look at option number D. And I want you to see this portion here, where we have something like C double bond C double bond C. Now this thing is known as a cumulated diene. Where double bonds are together, we call it a cumulated diene, and cumulated diene are very less stable. So this is also not correct, right? And so the two tautomeric forms that 2,4-pentane dione is mostly found in is either A or B. Okay, and now let's look at which of the following is the correct answer. So of these, option number B is correct, and I will show you why. Okay, so let's look at the reasons why option B is the correct answer. The first thing that you should note is this carbon-carbon double bond. It is inside the chain rather than at the corners, right? And we know that the more substituted alkene is more stable. Okay, let's look at the reason number 2. For that, I will redraw the structure of this compound and you will see what I am talking about. Okay, so molecules can rotate themselves in free space and they can have an orientation like I have drawn in the figure. Now look closely at this hydrogen atom and this oxygen. The oxygen atom has lone pair and the hydrogen atom is very close to it, and you know that oxygen and hydrogen can form a hydrogen bond, and you will get a ring-like structure in this compound. Also, if you count the number of atoms in this ring, you will see that it has 1, 2, 3, 4, 5 and 6 carbon atoms. And this is the second point. 6-membered rings are very stable. Finally, because of the presence of this hydrogen bond, the stability of this enol form also increases. So because of these 3 factors, we can say that option B is the most stable enol. Okay, now let's check out the second question that was asked by Pankaj. Which of the following compounds can exhibit tautomerism? Okay, so for tautomerism, you must have an alpha hydrogen present in the compound. What is an alpha hydrogen? See, the carbon atom that is attached to the C double bond O group, here or here, these carbon atoms are called alpha carbons. if these carbon atoms next to the carbonyl group have a hydrogen attached to them, then that hydrogen will be known as alpha hydrogen. So looking at these options, the compound C has a carbon atom at the alpha position which has hydrogen atoms present there. Therefore, this compound will exhibit tautomerism. So guys, if you found the video useful, please leave us a like and subscribe to our channel.